Hello and welcome to this year's Virtual Developer Summit. My name is Ann Fitz, and I'm here with my colleague Jose Banuelos. We are both product engineers on the ArcGIS API for JavaScript team. Today we're going to talk to you about building web apps using your GeoJSON, CSV, and OGC data. I just wanted to briefly go over what we will cover today before we dive in. First, we'll talk about using external data with the ArcGIS API for JavaScript, and then we'll move into some specific data types and create some awesome web apps using this data. In this session, we will talk about GeoJSON, OGC, and CSV data. So first, we're going to talk about using external data with the ArcGIS API for JavaScript. I wanted to show you all this guide page that talks about basic programming patterns in our API. On this page, there's a section called Working with External Data Sources, and it contains all of the different layer types that we offer that use external data with more information like features and limitations, and links to the layer's documentation. All of these layers mentioned here are just different subclasses of the layer base class based on their data type. Bringing data into your app as a layer with the JavaScript API could not be easier. The typical programming pattern for creating a layer would be to add that layer type in the require statement, and then use a code snippet similar to this one, where you would replace layer with the appropriate layer type based on your data, set the URL property, and then add any additional properties that your layer might require. So now I'm going to pass it off to Jose, who will talk to us about the GeoJSON layer type.
Thanks, Anne, for that wonderful introduction. In this section, we will discuss what GeoJSON is, a little history and its features. We will then dive into how we can use this data format with the ArcGIS API for JavaScript to take advantage of its features. First, a little history behind GeoJSON. So, GeoJSON is a geospatial data interchange format based on the JavaScript object notation JSON. The GeoJSON specification was first published in 2008 and later replaced in 2016 by a new specification, what we know as RFC 7946. These specifications illustrate the features and standards for this data format. The RFC standards state that a GeoJSON object may represent a geometry, a feature, or a collection of features. All GeoJSON coordinates must use the World Geodetic System 1984, also known as WGS84, with longitude and latitude decimal degree units. GeoJSON supports the following geometry types and geometric objects: feature collection, feature, point, line string, multi-point, polygon, multi-line string, multi-polygon, and geometry collection. The table shows the supported geometry objects from GeoJSON and their corresponding geometry types in our API. The API provides a GeoJSON layer to fully support GeoJSON data sources. The layer allows you to load the data by referencing a URL, as you can see here. If you'd rather load a GeoJSON object into the layer, you can do that by creating a blob. We won't get into much detail with this alternative workflow, but if you're curious as to how you can use a blob to load GeoJSON objects, you can take a look at our blob sample demo that will be provided with the rest of our demos for this presentation. The API allows users to take GeoJSON data and visualize the data with features that are available with the feature layer as well as some of our other layers. For instance, the feature reduction property allows us to cluster points. Since the GeoJSON layer is a client-side layer, it will store all of its features on the client side when they load. Therefore, all subsequent queries will not require server requests. The API also allows users with GeoJSON data to access their data in its many widgets. We have a demo where we utilize the time slider widget with our layer coming up soon to demonstrate this. As mentioned earlier, GeoJSON coordinates must use WGS84. Because of this, the maps were limited to using WGS84 or Web Mercator spatial references in earlier versions of the API. Now, the GeoJSON layer can be projected to a map's coordinate system. While the data will still be limited to WGS84, the map or base map can be in any projection. And now let's jump into our demo to see what we can do with the GeoJSON layer. In this first step, we're going to load our GeoJSON layer. So to do that, first we have to load our GeoJSON layer module, and we're going to initialize our GeoJSON layer. So this data that we have here is USGS earthquake data, and we've also configured a template to use for our pop-up template so we can get some more attribute data when we click on these features, and then we're going to load that layer onto our map. So let's take a look at what our app looks like with just loading our GeoJSON layer. So as you can see here, we have our point data, and we can gather some more information with our pop-up template. Now let's move on to our next step, where we're going to load our layer and onto a couple of widgets. In this step, the two widgets we're loading is the legend widget and the expand widget. So we're importing modules here, and so we initialize both of our widgets down here. So the legend's just going to help us view some of the symbols from the layer in the legend, and the expand widget is going to allow us to toggle the legend on and off as we please. So let's take a look at how our application looks now with our two new widgets. As you can see now, we have our legend widget displaying that simple marker symbol, and we can toggle that legend on and off with our expand widget. So this is an example of how we can use our GeoJSON layer with a couple of our widgets in our API. So let's go on to the next step, where we're going to go ahead and apply a render onto this layer. So in this step, we're going to add a render to our GeoJSON layer. In this example, we're going to be utilizing the class breaks render. So we're going to take advantage of the auto casting so we don't have to import the class breaks render up here with the other modules. So we're going to go ahead and get started with defining that. The symbols we assign based on a range of values. In this case, we will be using the magnitude field from this data. And we can take advantage of this render to symbolize the earthquake magnitude classifications. Classifications, we use some earthquake data sources and just to set our min and max values for our class breaks. So we also assign some labels, which we will be able to see in the legend widget. And now we go ahead and assign that render to our render property for GeoJSON layer. So let's go ahead and take a look at what our application looks like now with our class breaks render. We now have the class breaks render on the GeoJSON layer applied, and we can use the legend widget to help us distinguish between the features in the map based off their symbol colors. The lighter shade of yellow represents the micro earthquakes, which have a magnitude of less than 3. The darker reds represent strong earthquakes, which have a magnitude between 6 and 7. Now that we have a render, let's go ahead and add some clustering to this application. To add clustering to our application, we will use the feature reduction property of the GeoJSON layer. The following is an object representing the configuration we will use to set up clustering with our layer. We have our pop-up template, where we will receive some statistical data from the features that make up each individual cluster. So we have the total count and the average magnitude of earthquakes that make up each cluster. Using Arcade, we will display a nice description in the pop-up with a summary that gives us some classification on the average earthquakes that make up a cluster. So we'll get a more descriptive pop-up with this. If you're curious and want to learn more of what you can do with clustering, we will have some additional presentations on clustering during the Developer Summit. Once we have our config finalized, we're going to go ahead and sign assign that cluster config to our feature reduction property of the GeoJSON layer. Now let's look at our application with clustering enabled. And this is our application. So if we zoom in, we can see those clusters and we can see there's 655 earthquakes here. If we click on this particular cluster, we'll get some more statistical information. We'll get the number of earthquakes along with the average magnitude for the earthquakes in this particular cluster. And so that just highlights what the features that we can use from clustering with our GeoJSON layer. So let's go into the final step and add some client-side filtering. Looking at our new index.html file, we have added a new select element or a drop-down with options representing the magnitude ranges of our earthquakes. For this example, each value has a SQL expression that we will use to filter our layer. Here, we are initializing our layer view. We will use the select element added and add an event listener to it. So whenever we change the option in the dropdown, the layer view will filter the features that satisfy the SQL queries we assigned to each option. So now let's take a look at our final application with all our features that we worked on in this demo included. Now we have our clustering, our class breaks render, and we can go ahead and filter by magnitude. So let's take a look at the minor earthquakes. And we can also filter by some of our moderate earthquakes. You can still see some of that information, statistical data from our clusters in our pop-up template. So I hope this demo helped illustrate at least one or more new features that you may not have been aware of that are capable with our GeoJSON data. So I hope you all go and apply these to some of your GeoJSON data applications. So thank you for watching, and I'll go ahead and pass that along over to my partner Anne so she can talk about the OGC feature layer.
Thanks for that great demo, Jose. So next we're going to talk about OGC data. OGC stands for the Open Geospatial Consortium, which is a global community that creates geospatial standards for the web. We support 4 different OGC data types and have a layer for each one: WMS, WMTS, WCS, and OGC API features. So today we're going to focus on the OGC feature layer, which gets its data from an OGC API feature service. This is one of the newer OGC data services. Part 1 of the specification was just published in October of 2019, and we added support for this in our API this past summer. The service is comprised of geospatial data stored in collections, and it was previously referred to as WFS3 before it was published. So if you're familiar with WFS, then this is similar. This is a feature service, so by using this layer type, you are bringing features into your map and can interact with them in a similar way as features from a feature layer. This layer supports rendering, labeling, pop-ups, querying, etc. So to create the layer, you just have to specify the URL to your service and the collection ID, and then you're ready to go. So before we get into the demo, I wanted to show you all what it looks like when viewing an OGC API feature service on the web. So this is the service I will be using for my demo today. And here I can click to view the collections in this service, and it lists all the different collections of features that are available. So today we're going to look at windmills in the Netherlands. So I click on that service to learn more. From here, you can browse the data and view additional information with these links down here. But the main thing we're looking for on this page is the collection ID, which we can find up here in the URL. So in this case, it's Dutch_windmills. And now that we have the URL to our service and the collection ID for the features we want to show, let's see how we can create the OGC feature layer and add it to a map. Okay, so now I'm going to open up VS Code. You can see we have a similar setup as Jose did in his first demo with the CSS file, a JavaScript file, and an HTML file. So here you can see we are bringing in the OGC feature layer in our require statement. We have it right here. And then to create the OGC feature layer, we're giving it the name, variable name of windmills layer. We're saying new OGC feature layer and specifying the URL and the collection ID of Dutch windmills. We're just going to put that on a gray vector base map, add the layer here to the map, and create a map view with the extent set on the Netherlands, where our data will be. Let's take a look at what that looks like. Okay, so here is what we initially have. This is just using a default renderer. So it's this orange symbol, but you can see this is where all of the windmills in the Netherlands are located. So to someone looking at that map, they might not, if they didn't know exactly that we were talking about windmills, they might be a little confused as to what the map is trying to show. So we can give this a better renderer to kind of give a little more information about what we're trying to show. So here we will add a renderer on the OGC feature layer. We are going to just do a simple renderer. And for the symbol that we're going to use, we're going to use a picture marker symbol of a windmill. And I'm just going to copy and paste that in because it's a little bit faster. So I have this windmill icon that we'll use. So now that we have our renderer set, let's go back to our app. Let's refresh and see what it looks like. Sorry, it's a little slow to load. Those are a lot of features in there. So now you can see this is giving us a little bit more information. We can see this is a windmill, and there are definitely a lot of them in the Netherlands. Okay, so next we're going to add a pop-up to each feature, just to provide a little more information on the windmill based on the data provided from the service. So I'm just going to copy and paste here just because it's faster, but right now we are adding a pop-up template to the OGC feature layer. We're giving it a title, and for this service, all of the field names are in Dutch, so I'm not even going to try to pronounce these because I don't speak Dutch. So we're giving it a title, which this translates to name of the windmill, and then we are going to add media content to the pop-up. So in this case, we're adding an image media and linking the field names for the image thumbnail and URL. And then we also want to add some fields to our pop-up so we can have more information about the windmill, such as the name, location, type, condition, and link. And then down here in the view, we want this pop-up to be docked off to one side of our app. So we are going to add on the pop-up property of the view, we're going to set dock enabled to true, set some dock options. So we want the pop-up docked in the bottom right corner of our app. And yeah, that should do it. So let's go back to our app. Let me refresh. And now let me click on one of the features to get the pop-up. So here we have a name that I cannot pronounce. We have a lovely picture of this windmill, and we get a little more information, the location, type, condition, and link to view. Okay, so next, the last thing we want to do is add to our app some client-side filtering. So you may have noticed that each windmill has a type. And from looking at the data, I found that Poldermullen and Karenmullen are the most common, and please excuse my pronunciation. So I want to create a filter that will show where those windmills are on the map. So let's go back to our code, and we're going to look at the HTML file right now. So we want to create a custom element to do our filtering and querying from. So we'll start by adding this windmill filter div to my HTML, and I'm going to set the class to Esri widget so that the styling is consistent with the rest of the UI. And you can see here that I'm providing 3 different categories to filter. So one is that cornmullen, one is the poldermullen, and then an other category. So next, let's go into our CSS file and add some styling around those elements that we just added. And again, sorry for just copying and pasting, but it makes it quicker. So we have some styling there, and now we're ready to go add things to our JavaScript file. So we'll start by adding an expand widget in the require statement, which allows content to be shown or hidden. So we're going to use that to display our filter element in the view. And we're also going to want to do our querying and filtering on the client side so we can avoid making unnecessary requests to the server. So that means we want to use a layer view to apply the filter. So we'll start by defining this windmills layer view at the top of the file. So next, I'm going to go down to the bottom. We're going to use the view.whenLayerView function to get the layer view once the layer has loaded. So let me just add that. And inside of this, we're setting the layer view that we just got to the windmills layer view that we just defined earlier. And we're also going to create that expand widget that we just added for the windmill filter element and add that to the top left of our view.
So to actually do the filtering, we're going to need to get the windmill element and create a click handler on it. So here we're getting the element from the HTML and we're adding an event listener for click, and then when the windmill element is clicked, we are going to run this function called filter by type. So let's add that. So in this filter by type function, we're getting the selected type from the windmill filter element, and we are creating a definition for the filter based on that type. So once we have the filter defined, then we are going to set an effect on the layer view and apply the filter with the filter definition we just defined. And we're going to set for the objects, the features that are not included in the filter, we're going to set their opacity to 20%. So it'll highlight the features that are included and really dim out the ones that are not. So let's go take a look at our app. Here we can see that we have this little filter icon in the top left. So we can click on that and that will expand our filter list. So I'm going to click on this and you can see that the features that are not included are grayed out, and if I click on one of these features, you can see that this is cornmullen, which is what we clicked on. So it works very quickly to filter the features and set an effect. And if we look at the network tab, you can see that no additional requests are being made when I change the filter, because this is all happening on the client side. All right, so that's all I have for you about the OGC feature layer. I'm going to pass it off to Jose, who will talk to us about CSV. Take it away, Jose.
Thank you, Anne, for that cool demo. So I bet More of you are more familiar with CSV data, whether you have used it in your web applications or even just reading an Excel spreadsheet. CSV is a plain text file format used to represent tabular data and can include geographic point features. This tabular data is very simple and easy to generate, import, and export from applications or programs. The ArcGIS API for JavaScript CSV layer allows us to utilize the location or geographical data in a CSV file and visualize it on a map. The CSV layer expects latitude and longitude coordinates, so it will automatically detect these fields. For the latitude field, if not specified, the API will automatically look for field names in the file such as lat, latitude, y, and a few others. For the longitude field, if not specified, the API will look for field names such as lon, lng, longitude, x, and a few others. You could see these in our API reference for the CSV layer under the latitude field and the longitude field properties. The common approach to load a CSV layer is via URL pointing to the CSV file, as you can see in the code on the slide. The CSV layer takes advantage of the same capabilities as the GeoJSON layer. This layer is also a client-side layer like the GeoJSON layer, so it loads all of its features on the client side on initial load. The rest of the queries operate on the client side. In the demo coming up, we will take advantage of one of the client-side layer features, and that is the ability to upload the CSV file directly from your computer and visualize the data immediately on a map. This will save some valuable time for us all. So let's have some fun with the CSV layer and on to our demo. In the first part of our demo, we're going to go ahead and load our CSV layer onto our map. So the first step is to reference the CSV layer module in our require statement. Next, we're going to initialize the CSV layer. We're using a URL for this first step, and the data we're using is hurricane data from the National Oceanic and Atmospheric Association. So we are also creating a template just to get some more information on each feature. When we click on each feature in our map, we're going to go ahead and then load our layer onto the map. And let's take a look at what our application looks like now with our CSV layer data. As we can see here, our CSV layer is some point data, each point representing a hurricane. And if we click on a point, we can get some attribute information from this particular feature. So that's first step with loading our CSV layer via URL. We're going to go ahead and to the next part and add a couple widgets to this application. Just like our previous demos, we're going to add a legend and expand widget as well to our application. So we're going to reference modules to the legend and expand widget in our require statement, initialize both widgets, and as mentioned before, the expand widget will be used to hide or show the legend widget as we please. So let's take a look at our application now with both of these widgets included. As we can see here, we have our legend widget showing the default symbology for this CSV layer, and we can hide and show this legend as we please. So let's go ahead to the next step where we apply a renderer to this layer. We're going to go ahead and define our unique value renderer by utilizing, again, the auto casting feature of our API, and so we can define it right here. The unique value renderer allows us to symbolize features based off the matching field values. So the field from which we define the unique types in this example is the category field of the data. The symbols we are using are picture marker symbols. The larger the value of the category field, the larger the diameter of the picture marker symbol that is being used. So this renderer will allow us to distinguish the hurricanes visually based off this category field. So once we have our unique value renderer defined, we're going to go ahead and assign that to the renderer property of our CSV layer. So let's go ahead and take a look at our application now with the unique value render applied to our CSV layer. This is the CSV layer with the unique value renderer applied. If we take a look at the legend widget, we can distinguish between features based off the size of the point. So the category 1 has the smallest diameter, whereas the category 5 has the larger diameter. And so now that we have the renderer applied to our layer, let's go ahead to the next step and add a time slider widget to this application. This step demonstrates how to use the temporal data of the CSV layer in the time slider widget. So the first step is to add our time slider widget to our application. And we're going to do that by referencing the time slider module in the require statement, which we should have ingrained in our brains by now. So let's go ahead and initialize the time slider widget and set an interval of 1 year. So every time the time slider progresses, it's going to progress by 1 year. And we're going to add the time slider widget to our UI in the bottom right-hand corner. Next, we're going to take advantage of the layer view and utilize some client-side filtering. So first, we're going to set full time extent of the time slider, which defines the entire time period for which you can visualize your data with the widget. So next, we're going to add a watch on the time extent property to watch for any changes in the time extent values. So that means whenever the time slider widget changes, this event is going to be fired, and we're going to go ahead and take advantage of the layer view effect property to do some client-side filtering. So the layer view effect property will not hide the features that do not satisfy the time extent of the filter. It utilizes the excluded effect property to gray out these features instead. It will appear that the features that satisfy the extent of the filter are highlighted, but in reality, the excluded features are just grayed out with a lower opacity. So let's take a look at what this looks like with our application. So this is our final application with the time slider widget added on the bottom right-hand corner. If we click on the play button, we'll see that the time slider widget progresses by year, and we can see that the data is being filtered. So the hurricanes that satisfy that particular time extent in the time slider widget will appear to be highlighted, but in reality, the rest of the features that don't satisfy that time extent are actually just being grayed out. So this is another example of the cool features that we can utilize from the JavaScript API and utilize them with our CSV data. Before I end this demo, I wanted to quickly demonstrate what I promised earlier I would show: the ability to manually upload a CSV file from your desktop via a file picker or with a drag and drop. So I'm going to go ahead and drag and drop the same hurricane data from our CSV layer, but now as a direct file upload. So as you can see, we can achieve the same functionality with a direct file upload of the CSV file as we would when using a URL. This is a neat workflow you could use when you want to display your data right away. You can just drag and drop your CSV file and boom, your data loads on your map. So this full application is part of our demo applications that come with our presentation. So you can take a look at that and utilize some of that code there if you want to maybe use that in your applications as well. So thank you for watching this. That's it for this demo. Hope these demos were helpful and you learned some new tricks to take full advantage when working with GeoJSON, OGC, or CSV data. So thank you. The demos and slides for this presentation are available at the following link. Please provide your feedback for the session by clicking on the session survey link directly below the video. Thank you all once again, and enjoy the rest of the Dev Summit.